Okay, finite math students, I'm going to do a video that will cover some of the problems in your chapter 4 homework. I realize I probably should have made this video for you last week, but things are busy here with my family, and I was also busy going over some of your chapter 3 uh, test problems, and I had to make a video to try to help you guys out with that one and answering your questions and answering your emails. So it's been kind of busy. Okay, so the first problem I'm going to do, I'm just going to concentrate on problems like in the last third of your homework, because the problems at the beginning I think are actually pretty easy and straightforward. The problems later on are a little more challenging. Okay, so let's take a look at the problems later on in your homework where I think you will need a little bit more assistance or guidance. So let's look at problem 133. Find A, B, C, and D so that the product of the two matrices is equal to, this matrix 4, -4, 5, -8. So let's see. We're looking for the product of these two matrices, and the product is right over here. Let's use Mathematica for this, because this is something where this is the type of thing that Mathematica is really extremely good at. Okay, so let's see if I can erase that. Okay. So first of all, let's see, matrix A is equal to 2, -1, that's the first row, and the second row is 3, -2. So as you can see, right, matrices in Mathematica are really lists of lists. Okay, so this is a list, right? And this is a list. And when I put several lists together in one list, in one larger list, that is a matrix. Okay, and let's see what it looks like. Semicolon, a matrix form. Okay, looks great. And matrix B is equal to AB, AB, that's the top row, and CD is the bottom row. And let's see what that looks like, okay? A, B, C, D. Okay, terrific. Well, let's do the multiplication, okay? So AB, not A space B, okay, or A space capital B, no. AB is equal to the product of A and B. And for that, I'm just going to use the dot. In Mathematica, the dot means matrix multiplication. Okay, in Mathematica, the dot means matrix multiplication. Okay? And let's see, let's make that look pretty so we can see what we're dealing with. Okay, so these are the equations that we have now, right? We have, let's see, we have 2a minus c is equal to 4. Okay, so that's so this is equal. This is supposed to be equal to the matrix 4, -4, 5, -8. Okay, so this expression here has to be equal to 4. This expression here, 3a minus 2c. That's the phone. Let's just ignore the phone, okay? 3a minus 2c is equal to 5. 3a minus 2c is equal to 5. Excuse me. Let's just ignore the phone. Could someone pick up the phone? Ugh. Okay. And then this expression right here is equal to negative 4. So that's going to be 2b minus d is equal to negative 4. And then this expression here is equal to negative 8. So we have 3b minus 2d is equal to negative 8. Okay. And there you have it. So those are the 4 equations that we have in 4 variables. Okay. Those are the 4 equations that we have in 4 variables. Okay, so let's see if we can make this work. All right. There are several ways of doing this. Let's do this the long way because you guys need to learn Gaussian elimination. All right. So I'm going to call it my matrix is equal to, let's see, so we have A, B, C, D, lowercase a, B, C, D, is that correct? Let's start with this equation. It really doesn't matter which one is first, second, third, or fourth. It really does not make a difference. Okay, it makes no matter. So we could start here, right? Or we could start here. I mean, it really doesn't matter which equation is first, second, third, fourth, okay? So I'm going to start with this one right over here. I'm going to start with, this equation right over here, okay? So then there's no A. The coefficient for B is 2. There's no C. The coefficient of D is negative 1. It's equal to negative 4. Second row. There's no A. Okay. The coefficient of B is 3. There's no C. The coefficient of D is negative 2. And then the answer is negative 8. Third row. So for the third row, guys, I'm down here. So then the coefficient of A is 2. And then B. The coefficient of negative C is, the coefficient of C is negative 1. There's no D, and then that equation is equal to 4. And then on the bottom, I have the coefficient of A is 3. The coefficient of B is 0, and then I have negative 2. That's the coefficient of C, negative 2. There's no D, and then that equation is equal to 5. So my matrix form. Okay, let me erase this stuff over here. Okay, so the whole process of Gaussian elimination. So this column here has to be transformed. Actually, what I really want is this. I want 1, 0, 0, 0, 0, 1, 0, 0. And then when we're done with those columns, we go to the next column and we have 0, 0, 1, 0, and then 0, 0, 0, 1. And then these numbers will change accordingly. Those numbers will change accordingly, okay? So let's start with the column all the way to the left. Is there a number that I can multiply 0 by in order to create 1? And the answer is no. So I'm going to have to swap rows. All right, so what if I put Oops. Hold on one second. Here, let me start that over again. There we go. What if I put the third row up here? Okay, and I can do that. So my matrix, okay, we're going to swap the first and third rows. All right, we're going to swap the first and third rows. Oops, wait a minute. Why did that not work? Hold on one second. Oh, I see. Okay, I see exactly what happened. I swapped elements. Sorry about that. Okay, that's not good. Let me erase that and let's start this over again. Let me shift enter on this again. Shift enter. Okay, let me make sure this is okay. My matrix form. Okay, so that's kind of weird. Let me. Oh, okay. I remember. Sorry about that. Okay. I had a lapse of memory for a moment. Sorry. So, if we're going to swap rows, okay, now I actually think I forgot how to get this accomplished. One second. My matrix. Well, this is going to be the first row. And this is going to be the third row. And that's actually the first to third rows. Now, okay, so 1 second. Let me erase that. Okay, so there is an easy way to do this, and I forgot. So I'm going to have to look this up. All right, I am going to have to look this up. Okay, so let's go to Google. Swap rows in Mathematica matrix. It's really easy. Oh, here we go. Now I remember, and it is actually really easy. Okay, I forgot how to do that. Okay. So here we go. The information is right over here. Okay, good. Okay, let's do this. So my matrix, sorry about that. First and third is equal to my matrix third and first. My matrix form. Okay. So now I can see that I switched the first and third rows of the matrix. I almost had the right syntax, but I forgot the list braces right over here. I forgot about that. Okay, now my goal is to change this 2 into a 1. How do you do that? Well, multiply the entire row by 1/2, right? So row 1 is going to become equal to 1/2 times row 1. And that's pretty easily done. My matrix, first row, is equal to 1/2 times my matrix, first row. My matrix form. Okay, we have zeros over here already. These are zeros already. Okay, so this has to become a 1. How do you do that? I'm sorry, not a 1. It has to become a 0. This number 3, this element of 3, excuse me, this element of 3 has to get replaced with a 0. So how do you do that? Okay, well, which row is it in? It's in the 4th row. So you're going to take every number in the 4th row minus 3 times every corresponding number in the 1st row. Because 3 minus 3 times 1 is 0. And then you're going to get, okay, you're going to get exactly what you want. Okay, and what you want is a column. You want a column where the first element is 1, and then all of the elements below are 0. So then we go over here to this number. This number 3 has to get changed into 1. That number 3 has to get changed into 1. How do you change 3 into 1? 3 multiplied by the reciprocal of 3, that's going to be equal to 1. Okay, so let's try that. My matrix 2, second row, because the 3 is in the second row. Okay, and this is equal to 1, oops, sorry about that. That's equal to 1/3 times the second row. And then this number here, this 2 has to become a 0. So how are we going to do that? Well, my matrix 3, because I'm looking at the 3rd row, is equal to my matrix 3 minus 2 times my matrix 2. Why am I referencing the second row? Because the second row contains the 1 that I just created. Okay, so my matrix form. Okay, so now the first 2 columns look great. The first 2 columns are canonical. These 2 columns, okay, they are called canonical columns. All right, hold on 1 second. Canonical columns. Okay, we're going to have to do the same thing here. Now the problem is this is supposed to be a 1. This is supposed to be a 1. You can't change 0 into 1 through multiplication. So these 2 rows are going to have to get swapped. Okay, easily done. My matrix, the 3rd and 4th rows, and we're going to swap them. My matrix, okay, 4th and 3rd rows. Okay, so I just switched the 3rd and 4th rows because I can't have a 0 number. I can't have a 0 entry right over here, because you can't use multiplication to change 0 into 1. So I'm manipulating the 3rd row. I'm going to multiply by the reciprocal of -1/2, which is -2, times the third row. And what do I get? Okay. And I have a 1 here, which is great. 0, 0 looks good. Okay, so now this has to become a 0. That has to become a 0. Okay. So the first row changes. Okay. My matrix first row plus, why is it plus? Because this is a minus. This is a minus, okay? Plus 1/2 times, where's that magic 1? It's in the third row. Okay. So now these three columns look great. Actually, it's kind of sloppy. Let me do that again. These 3 columns look great. They look fantastic, okay? So now this number, the 1/3, is going to have to get changed into a 1. Let's try that again. The 1/3 has to get changed into a 1. How do you do that? We're going to multiply every single row by the reciprocal of 1/3, which is 3. Okay, so my matrix, excuse me, my matrix, I'm manipulating the 4th row, is equal to 3 times my matrix, 4th row. And things are looking good. I have a 1 here, 0, 0, but this has to get changed into a 0, right? How do you do that? Well, we're manipulating the second row, so my matrix second row is equal to my matrix second row plus 2/3 times my matrix. Where's the magic 1? The magic 1 is in the 4th row. My matrix form. Okay, and there you have it. There you have it. So let's see if we can make sense of what we're looking at here. So my matrix, let's see, prepend, my matrix A, B, C, D answers. Okay, so we can see that A is equal to 3. This part, you don't really have to do this part, guys. I'm just doing this as an instructor to help you visualize the solution, but I mean, you really don't have to do this unless you really want to, okay? But A is equal to 3, B is equal to 0, C is equal to 2, and D is equal to 4. And let's see if that's the right answer. That is the right answer, okay? So the problem's not too bad. The hardest part for me was just remembering how to swap rows, but that shouldn't be a big deal. I mean, if you're not sure how to do something in Mathematica, Google it. Just look it up in Google. So how do you swap rows? So here's another matrix. Another matrix is, how about A, B, C, X, Y, Z, another matrix. Oops, matrix form, okay. And let's say I want to switch those two rows, another matrix. So I'm just going to switch those two rows. And there you go. So now XYZ is on top and ABC is on the bottom. And I think you can do the same thing with columns. Let me experiment. That might be a little trickier. Let's see. Another matrix. I mean, I could always look it up. I usually don't have to worry about changing columns, but let me see. So, okay, that's another phone that's ringing. Let's ignore that. Another matrix. So, all rows. Oh, let me see. All rows, second column. I wonder if, let me see here. Another matrix, all rows, third column. Oh, I see. So that doesn't, so I'm getting an error message. So, yeah, so this matrix hasn't been changed. Another matrix, matrix form. Okay, so let's try it this way. Another matrix. So all rows, second column is equal to, oh, but then you know what's going to happen. Let me see here. I'm trying to switch the second and third columns. I can always look that up, but let me see here. This may not work, but that's okay. It's for this problem, we didn't really need it, so I'm not going to worry about it. All rows, third and second columns. Another matrix, matrix form. Yeah, so that actually did work. So it's following the same format. It's following the same format as before. So if I want to switch the second and third columns of the matrix, then I select all of my rows here and I simply put 2 and 3 into a list, and then I reverse it. I put 3 and 2 into the list here, and so here you can see YZ, YZBC, but here I have ZCYB. So I actually switched the second and third rows. So here I have, I'm sorry, not the second and third rows, the second and third columns. So this is the first column, the second column, the third column, okay? And then here, I have the first column, the third column from the matrix above, and then the second column from the matrix above, all right? And this is how you would actually do it right over here. This is how you would actually do it right over here. So switching columns is something you normally don't have to worry about too much when you're doing these problems, but you do have to know how to switch or swap rows. You have to know how to swap rows. When you're doing these problems, guys, you normally don't have to worry about swapping columns, but you do have to know how to swap rows, all right? You have to know how to swap rows. Let's take a look at one more problem. Let's see. Hold on one second. Well, we can do... Okay, so here, let's look at number 129. This is actually pretty easy to do. Using Mathematica, it's really easy to do. All right, so here we're going to have clear, okay, wait a second, clear matrices A and B. Okay, so A is equal to AA, BB, B is equal to AA and negative A, negative A, negative A. So this is what A looks like, and this is what B looks like, okay? That's what A looks like, that's what B looks like. So it's asking, find AB and BA. So let's see. Okay, so A times B is equal to, A times B is equal to the 0 matrix, the 2 by 2 0 matrix. And that's just 0, 0, 0, and 0, okay? And B times A, okay, well, that's going to be equal to A squared plus AB. Okay, so let's just ignore the telephone, guys. Of course, when I'm making a video for you guys, that's when a lot of people decide that they have to call me, right? Okay. A squared plus, oops, plus AB negative A squared minus AB, and then negative A squared minus AB, and let's see if that's correct. Okay, very easy. Very easy to do with Mathematica. All right, guys, I'm going to try to make another video for this homework assignment. Things are a little bit crazy today, and I'm getting a lot of phone calls. So obviously, you know, I don't know if God wants me to spend a lot of time making a long video today, but I will try to make another video for you guys within the next couple of days for this homework assignment, okay? All right, take care, and I think that's going to be enough for now. All right, have a good one. Bye-bye.